Okay, so how everyone? So I'm glad to see you here again. Today I'm going to talk about Module 9, Pandas. Pandas is a very powerful library for data analysis on both quantitative and qualitative data. There are two main data structures. A series is similar to a one-dimensional array, and a data frame likes a multi-dimensional table. As Pandas is a third-party library, we need to import it before using it. To use a function in a library, we import the library using the import statement, like import pandas. As function assign an alias to a library to save the time of typing the full name. So here we type as pd. To use files stored on our computers, we need to put our files into a designated folder or read files through its path. Check Module 7, Section 7.3 for more details. So here, first we upload the files to the platform first. And we upload another one. So to import a CSV file, we type data1 equal pd.read CSV and then the final name. To import an Excel file, we type data2 equal pd.read Excel module 9b dot Excel file. We can also access a variety of datasets from online sources for our data analysis. If we know the path for an online store data, we can import it with the read function. Here, we place the CSV link and we are going to save it in DataFrame. Now, let's run it. It will take some time to download the file. After the file is downloaded, it will save to the DataFrame. And here you should be able to see the yield for different US Treasury securities. Application Programming Interface (API) is a connection between computer programs. For a program with API, we use the Python program to connect to this program and access the dataset in it. This module will connect our program to the database in data.gov.hk using its API. So here is the link. To start with, we import libraries that are used to get the data from data.gov.hk. First, we import URL library.request. Then, we import JSON. Lastly, we import Pandas as PD. We can also set our dataset to display all columns and rows. Here, we use the code pd.set option. Display maximum columns, none. It means we are going to show all the columns. And then pd.set option, display maximum rows. Also none to display all the rows. Then we input the URL for our data source and name it path. So here we already placed the URL. You can also get more information from the link above. Then we request the data from the URL and name it URL. Notice that the comment codes are all under the same block, so those lines should have the same indentation. So let's type with URL library.request.url open and then the path that we saved previously as URL. First, we request the data need from the data.gov.hk and name it bytes. Remember the next code should have the same indentation. Then we decode byte data into JSON format and name it JSON. And we load the JSON data into a Python dictionary format and name it data. So lastly, we input the dictionary format data into a Pandas data frame structure and name it df. So lastly, outside this block, we load df1. Again, it will take some time for loading, and now you should be able to see that we already get the data from the web. And here we got some population data. The table here show you the data categories in data.gather.hk that you can access. Pandas DataReader library can extract data from various online sources, such as stooq and WorldBank, into a Pandas DataFrame format. Details of these online sources can be referred to the following link. For Jupyter user, you need to install the Pandas DataReader package before importing it. So here we type py install Pandas DataReader. If we only want to use one function from a package, we can use the form statement to import the exact function. The syntax of form statement like this: form package import function. Import package means we are going to import the whole library, which is more time consuming. We first import the function DataReader from Pandas DataReader package and call the function pd.out. Here we type from Pandas DataReader import DataReader as pd.out. Then we import the function datetime from datetime package, and we are going to call it a function dt. Then we use the function datetime to set the starting date and ending date. So now the starting date is the 1st of 2016. Lastly, we get a series of stock price from stooq with the function DataReader. So here we use series 1 pd.out 700.hk stooq start end, and then when you type series 1 and you run it, now you should be able to get the opening price, closing price, and high, low, and volume for 10 cents. The series function creates a one-dimensional labeled array to hold data of various types. A series of a variable is stored in a single column, while the first column is the associated index value for each value in the series. Here, let's type series2 equal pd.series and square bracket 100, 250, and 300. Now we are going to call the value with index 1, which is the second number. That's why we get 250. Series function allows us to give a label representation for each value. It makes us easier to call the value with its associated label. So now we are going to create a label. So they are Alibaba, Tencent, Meituan, and Xiaomi. Next, we are going to create a series that stores all the stock price. So 112, 396, 202, and 12. So lastly, we are going to set the series 3 as pd.series, and then the data would be the price, and then the index is the stock label. Now let's see what we can get if we type series 3 10 cents. And you should be able to see that the corresponding value is 396. If you type series 3, and you can actually get the dataset. We can also assign a label to each value in dictionary format. So here, let's try to type data equal Alibaba, and the corresponding value is 112, and then the label 10 cents, the corresponding value is 396, and then label Meituan, corresponding value 202, and then label Xiaomi, corresponding value 12. Then we save it into series 4 using pd.series, and when you call series 4, you should be able to get the same result as what we just shown. A data frame is a two-dimensional data structure with labeled assets in both end columns. In data analytics, variables are usually stored as columns, and observations are stored as rows within the data matrix. When we use the DataFrame function, we put the variable name in columns in the column argument and put the observation label in rows in the index argument. Here you can see that our data set is price, and index, which is the row, shown day, and then the column shown the stock name. So when you type df2, you should be able to see that now the stock name show in columns and year show in row. We can also write the data in dictionary format and assign a value vector to its variable in columns. So here we already set the data here, and then when you type df3 equal pd.DataFrame data index 2022, 2023, and 2024, then you're going to create a label to the dataset. And when you type df3, you should be able to see that now we have the dataset as what we shown previously. We are going to use some basic Pandas function for data management. So how about let's learn creating a data frame. Here we already have a dataset and we're going to save it in a data frame. First, I want to give some label. So here, info, name, gender, salary, job, address. Then we type df4 equal pd.DataFrame. So you are now going to create a data frame based on the data variable. And then columns is the info. When you type df4, now you should be able to create your first data frame. Then how about to convert all values in column salary as floating number? Then we can try to type df4 salary and equal df4 salary dot as type float. Now you should be able to convert all the value in floating numbers. And you can see that now they are shown with a decimal places. Next, we want to check where there is any duplicate rows. So here you type df4.duplicate and you should be able to see that now we got one duplicate row. And here you can see that index 0 is the same as index 2. So because index 2 already shown up before, so that's why index 2 is the duplicate row. Then how to display information stored in the first row. Then you can type df4.locate 0. Then you're going to show the information stored in index 0. Then how can we display a new data frame without rows that have missing value? You can use the drop NA function and you should be able to see that now all rows that have missing value is dropped out. In case you want to focus only for address, then you can set subset equal to address. Now you can see that we can recall index 1 because it only have the missing value in gender but not in address. Next, in case you want to fill the NA value, you can type fill NA F. Now you can see that all value that have a missing number or NA number now is filled with F. Previously, you can see that we didn't make any permanent changes. So in case you want to make permanent changes on the original data frame, we can use the argument in place equal to true. So here, we type the same drop duplicate and then we type in place equal true as a parameter. And for the gender, we want to fill it the NA with F. We also type in place equal true. And for address, we want to fill the NA field with central. Again, we want it to take place in the original data frame. So we also put in place equal true. Then we type df4.locate 3. So you're going to call the for row and then the gender, and then we want to replace it as M because originally is male, so we want to replace it with a M. When you type df4, now you should be able to see that we already cleaned up the dataset. Table 2 provides basic function for data cleaning, including figuring out empty cells, converting data types, replacing values, and deleting duplicate records. Table 3 provides function for getting basic information, including transposing a data frame, generating summary statistics, and producing a correlation matrix. That's all for module 9. Thank you for watching. If you want to get some practice, you can try to do the exercise here. So thanks again, and I'm looking forward to see you in the next module. Bye!